Why is this code considered bad? At first glance, it works. It syncs your data, it updates your UI, and it gets the job done. But look closer at the code. Every time you want to sync a single variable, you're manually firing a remote event, catching it on the client, and writing custom logic just to update a label.
But when your game grows, this simple workflow becomes a bottleneck. You're drowning in remote events for data that should just sync. So, what actually is an attribute? Think of every object in Roblox, a part, a script, or a player, as having a set of built-in rules called properties. You know these: name, size, transparency, can collide. These are hard-coded into the engine. An attribute is simply a custom property that you invent. It's a way to attach your own data directly to an object, exactly like the built-in properties, but with your own rules. In this example, I'm showing how a newbie would design their data replication. Before attributes, if you wanted to save a player's class or mana, you usually had to create a StringValue or IntValue object and parent it to a folder. It worked, but it was messy. It cluttered your Explorer and added extra instance overhead. Attributes replace that entire system. Instead of creating a new object, you just go to the Properties window, hit Add Attribute, and pick your data type, whether it's a simple number, a color 3, or even a C frame. You might be thinking, why does this actually matter? It's because attributes aren't just a stylistic choice, they are a massive performance unlock. Standard objects like StringValue or IntValue are full instances. Every time you create one, the engine has to allocate memory for a new object in the data model, manage its parent-child relationship, and track its individual properties. Attributes, however, are stored as value metadata directly on an existing instance. This means you're bypassing the overhead of instance.newParents, cutting down on instance bloat, and keeping your Explorer clean. For large datasets or high-frequency updates, you aren't just tidying up your code, you're literally reducing the work the Roblox task scheduler has to do. So let's put this into practice. Instead of setting up a massive folder system for player stats, we're going to attach our state directly to the player object. It's cleaner, it's faster, and it's completely reactive. On the server, we initialize our data with a single line, player:set attribute. No instance.new, no parenting, no folder bloat. Just the key and the value. From here on, whenever this value changes, the Roblox engine handles the replication for us automatically. But here is where the hidden feature lives. On the client, we use GetAttributeChangedSignal. This isn't a loop, and it isn't a remote event listener. It's a native engine signal that fires the exact microsecond that attribute updates. We connect it to our UI function. And just like that, we have a perfectly synced, high-performance data pipeline. But let's talk about the real reason this matters. Accessibility. Not every player joining your game is on a $3,000 gaming rig. A huge portion of the Roblox audience is on low-end mobile devices where every kilobyte of memory and every CPU cycle counts. When you flood the network with remote events, you're not just making the game slower, you're increasing the risk of memory crashes for your mobile players. Lower crash rates lead to a direct increase in your game's metrics. When your data pipeline is lean and reactive, your heartbeat stays stable and your session times go up. Roblox's discovery algorithm rewards games that don't crash and maintain high performance. By switching to attributes, you aren't just tidying your scripts, you're literally optimizing your game for the algorithm. Scalability isn't just about how many players you can fit in a server, it's about how many devices can actually run your vision. Using reactive attributes ensures that your game remains performant, professional, and, most importantly, profitable.